So this pipes and systems chapter is quite similar to time and work chapter. So we usually find in this chapter as there's a tank and there's a pipe A, let us assume it as pipe A and pipe B. Both are filling the tank or either simultaneously or one after another, or maybe only one is filling the tank. And there's a drainage pipe also, let us assume it as C. And they have different time, like let's suppose A is filling the tank in 20 minutes, B is filling the tank in 40 minutes, and C is able to drain the tank in 60 minutes. So all these times are like C is draining the tank in 60 minutes when it's working alone, and A is filling the tank when it's working alone in 20 minutes, and similarly B is also filling the tank when working alone in 40 minutes. Now the basic concept in this chapter, as we have seen in time and work, is of efficiency. So we'll try to see how to calculate the efficiency. So as we have seen in time and work chapter, we assume a particular amount of, like we assume work to be as a particular units which is divisible by the time taken in number of days. So in this also, let us assume that capacity of the tank, so because this is a work done over here, capacity of the tank in units which is divisible by this 20, 40 and 60. So the least common multiple of these is 120. So we'll assume the capacity of the tank as the capacity is 120 units. Now for calculating the efficiency of A, the total work done is 120 units. And efficiency is the work done per unit of time. So we know that efficiency is work done per unit of time. So from this, the work done is 120 units, and this work is done by A in when working alone in 20 minutes. So it becomes that the A is filling 6 units of a pipe per minute. So this is a capacity of A, like, or efficiency, or that A is filling 6 units of quantity of any liquid in the tank per minute. Now similarly we'll calculate the efficiency of B, and it would become as 120 by 40. So this comes out to be 3 units per minute. So this means that B is filling in 3 units of any liquid per unit of time, that is per minute. In 1 minute B is able to fill 3 units. Now what is the efficiency of C? That efficiency of C is 120 by 60. That is, C is able to drain out 2 units of the liquid in that tank per minute. In 1 minute, C is able to drain out 2 units. Now, if we know this efficiencies, if we are given that pipe A started initially and after 3 minutes pipe B is open, and thereafter after 10 minutes pipe C is also open, in how much time the tank is filled, something like that, maybe hours. So we know that we have already calculated the efficiency. We know that in 1 minute or per unit of time, whatever in that case a question may be given, we know that A is filling 6 units, in this case 6 units in 1 minute. So we can calculate from that, in if it's working for a particular like 3 minutes or 4 minutes, how much water is able to fill in, and B is 3 units per minute. And all this depends on that we have assumed the capacity of the tank as 120 units, because if the capacity is different, the efficiency will automatically become different because it is dependent on the capacity we have assumed. So when we are taking that A is working this amount of time, this amount of work, and B is working is like this, so we already know in that case that the capacity of the tank is 120. So if A is working for 3 minutes, A is filling in 18 units of liquid, and the total capacity in that case is 120. So from that Using these concepts, we can calculate, we can solve most of the question in this chapter.